Good. I'm Benjamin. I'm the developer advocate for the project. I look after a few things in the Zephyr project, the documentation, the code samples that were mentioned a bit before. And I, like many others in this room, actually, I also get to review quite a lot of code and get involved in code review and approving pull requests and so on, which is one area where things like LLMs can help. So I thought I would start with a very triggering maybe illustration. Some of you might be like, oh yeah, this is going to be an entirely AI generated presentation. It turns out that the topic that I want to talk about today, which is can LLMs and like ChatGPT, Gemini, and whatnot, and AI agents, etc., can they help or can they get involved in the way people do Zephyr stuff, writing code, documentation, reviewing, etc. And I tried to get some help from AI to put together the presentation, and it was clueless, interestingly. So I guess I'm not fully out of job just yet. And yeah, the rest of the slides are going to be mostly my own random brain dump, basically. And I hope we will have also some time for you all to give some feedback, because I'm pretty sure some of you have been using it one way or the other, or I've seen some Zephyr pull requests where GitHub Copilot was pulled in and things like that. Brief recap about what LLMs are in really just a few bullet points. And then, yeah, some of the things here in Zephyr land, this can help. And I guess for most of the, for the reviewing part, what will be interesting is that I will be, I guess, putting several hats on. Like I said, I tend to review a lot of code that's meant to be contributed to Zephyr. So it sort of has to meet Zephyr standards in terms of like coding guidelines, etc., etc. But code that you guys write that might not end up being contributed upstream. There's also all the reviewing aspect of it needs to be bug free in the first place, right? So there's many things involved in reviewing. So that we'll talk about that a bit. And then writing code is any good at writing drivers, board definitions, unit tests, things like that, documentation. And since the presentation is titled The Good, the Bad, and the Ugly, maybe we'll also talk a bit about that. So LLMs in a nutshell, those large language models, like ChatGPT, what was it, like 1.5? I don't even remember what was the first version, but large language models are those things where you feed them, like they've been trained on the corpus and potentially some Zephyr code, some Zephyr interactions on GitHub issues, etc. Like they know about a few things, and then you feed them with text, a prompt, and then it outputs more text, which can be effectively code. But this is sort of like self-contained. Whatever the model has been trained on, this is what's going to be helped to sort of predict the output based on the input and the prompt you're providing. The LLM by itself, and that's what we used to see when using ChatGPT.com and the like, I guess 2 years ago or something, it had like it wouldn't browse the internet. It wouldn't like, it would just answer based on what it's being trained on. So if you ask questions about Zephyr to like a plain large language model, it will answer based on its general knowledge, based on what it's been trained on. So it might be very broad, and it has no access to your CLI, no access to your hardware things. Whereas what we see more and more nowadays with Copilot in VS Code and Gemini in anti-gravity and Cloud Code and ChatGPT Codex, etc. For coding specifically, is more like AI agents. So the LLMs are still bringing some sort of knowledge, but then there's also the ability to interact with tools, and so and to get the human more involved in the interaction. So based on what's in the LLM and based on what your IDE effectively sees, your local source code, etc., etc. It can come up with a plan. You can get involved to review the plan, validate that it makes sense, and so the agent or the agents, plural, what we see more and more, they end up doing their work validating that whatever they're doing compiles and or meets the initial brief. They take notes. If I may do this kind of like analogy, they can write some files where they like, I don't know, they run unit tests or coverage tests and save the file that might or might not be used later for reference. And so they're much smarter, and that means that you can actually get some really good stuff out of them for Zephyr stuff. Starting with Zephyr code. Again, code that goes when I talk about Zephyr, I talk here about code that gets submitted to Zephyr, and the code that gets submitted to Zephyr, whoever submits it, hopefully they need their own like they had a colleague maybe review the code that they're about to submit, or maybe they used AI as well. We're going to talk about it. And then there's maintainers and collaborators in the Zephyr project that end up being basically swamped with code reviews. Might be slightly too small for you all to see, but the top 20 or so maintainers in the Zephyr project, in terms of how many pull requests are assigned to them right now, or as of maybe yesterday PM, it's dozens, right? And so they have to review lots and lots and lots of stuff, which yeah, I mean, it's literally thousands of open pull requests at the moment. So they have to do lots of context switching. They have to do lots of oftentimes repeating the same things over and over again. Many of those things, actually, I should mention, you may have experienced those pull downs that I certainly had when he did his pull request. We have our CI that runs like hooked into GitHub, and all the workflows that kick in to do some validation, automated validation in terms of code quality, like coding standards, spell check for things like, hey, have people used proper English in their comments, etc. But this is not perfect. You might still get false positives, by the way, and or stuff that still gets missed. And so that's yeah, a lot of code that needs to be reviewed, and a lot of stuff that fall through the cracks. Some of the stuff, one could argue, is fine, could be fine to just let go. Yeah, and sure, there's like a double, like an extra white space character in the code comment. Okay, sure, let's not be too strict there, maybe. But sometimes it's those like corner cases and off by one errors, which we all miss, and even like the automated tools often tend to miss. And so this is where AI can be really good, and LLMs can be really good. And so just yeah, sharing a few again brain dump or like sort of a few tips as to how I'm typically doing it in the early days. What I would do is just take whatever pull request I'm trying to review and get giving a hand to review. I would take the diff, like literally you go to the pull request, github.com/Zephyr project/pool/123. If you might or might not know it, like you can just add at the end .diff or .patch, like you get the diff or the patch. So I would do that, Control A, Control C, paste this into again, like an LLM, no agent whatsoever, like just think ChatGPT as of a few, a year or so ago, asking for things like, hey, how about this patch? So again, think like the LLM is not necessarily super Zephyr savvy, like it's just, it knows about like good programming, hopefully because it's been fed with lots of code snippets, etc. And you could ask things like, hey, spot really nasty bugs, like the things that humans would typically miss. Could be spelling typos. Think about stuff that automated tools would not catch. And please, pretty please, make the feedback concise, because I actually want you to help me and not add like a super verbose dissertation on like software engineering and whatnot. And yeah, focus on the most critical first, and then you paste the patch as I just described. And that's like, even if you were to use like even like open source large language models, you can actually get some really good results. I will put the slides online, but you could look at the a small sort of interaction I had yesterday based on, and it's not pointing fingers in any way at the author of this PR, but someone submitted an ADC driver, fed that exact prompt into Gemini that could have been anything really. And I got this actually really nice, it might not be 100% accurate, but it's really easy to parse through the results, which you get in like a minute, maybe, something like that. And focus on critical first. And it turns out that it said something, and I'll show the code right in the next slide, but it's saying something along the lines of, hey, you have a thread that takes care of acquisition, but the way you do error handling in there, whenever there is an error, rather than like continuing and trying again, you seem to be exiting your infinite loop. That infinite loop right here, like that acquisition thread, it has a while true, which we typically see in a thread that's meant to never end. So while true, read a raw ADC sample, but it might fail. If it does, break the loop. I think the author maybe meant, or I think AI thinks, but I would tend to agree, that the author probably meant that they want to continue. If there is like a glitch, you want to continue. Or even if that's intentional, I think that's feedback that's probably worth like discussing in the pull requests, and that's what shows up first in the analysis. And then there's a few other things, a bunch of things that are really just noise and or wrong. But usually, like what shows up at the top is worth. It points to some smells, let's say, in the code, which I think is good. And so that's the that's the by just using the model as a tool to, based on lots of code it's being fed into, it might spot those. Yeah, like whenever you have a while and a break, maybe that's not what you meant. Like people keep confusing continue and break, and that's maybe what's gonna what happen there. Other ways to review that are possibly more efficient, and this is maybe where like this one would be more. I want to review my own code before submitting it. So I am in my IDE, in Cursor, in VS Code, you name it. I want a peer to help me give feedback on the code. And so you could also trigger a very similar review right from the IDE using kind of a similar prompt, except that in your IDE, typically you would have more like an agent. So it would, as it kicks in, it would do things like, oh, this is an ADC driver that you're asking me to review. It is a TI ADC driver. Let's see if there's other drivers already to make sure that whatever you're trying to add, you're adding a new TI driver. Let's make sure that it's written in the same style. Let's see if there's code that could be reused. And so like those hints are, of course, also something that you can feed as part of your prompt. Like that's the kind of review you're looking for. Like, do you think I could have reused some macros in Zephyr I don't even know exist? And maybe the tool will like it will grab its way around to try and help you. And in fact, this is probably a good time to do a small digression on something that we see more and more, and that I wouldn't be surprised if we start adding into Zephyr repo at some point. All those tools, the cursor, the VS Codes, etc., VS Code plus Copilot of the world, there's some standards that are emerging so that in the repo itself you can store some instructions that help guide the agents. Typically, the agents nowadays, they are good enough that when you ask for a review, sort of automatically it will start wrapping its way around in your code base to see if you have, what does the README say? Are there any contributing guidelines? Are there coding guidelines? And so it will like spend a few cycles trying to discover those, or you give some hints using agents.md file or copilot instructions.md, or like those things that become more and more standard, so that you save some cycles and you make sure that no matter who's gonna make a review, the set of like important hints, they are really there for the LLM and the agent to pick up, except when they're not. Like my experience as of today, especially with GitHub Copilot, supposedly there's this thing where you can have like basically you put a few bullet points in a Copilot dash instructions.md file in your repo. And then whenever you summon Copilot asking it, her, them to do a review, it should look at that and follow the brief that's there, except that sometimes it just doesn't. I don't know. So it's yeah, it's getting there. Meanwhile, just like put whatever is yeah, whatever kind of feedback you're looking for and put it in the prompt. If you know, and this is where that's kind of my one of my takeaways. This is a tool. Obviously, this is a tool. It's really helpful, but it's even more helpful when you are looking for better or worse, when you already know your way around. Like if this is your first, say, I mean, we're going to move to writing code. If this is your first Zephyr driver, it will help you write a driver. Will it be like really well and perfect? Maybe not. If this is not your first driver and you already know like, oh, this driver is like super well written. This is Fabio who brought it. This one is too regular. I want to like I want to write a new driver for X. Please use this one as a reference because I know that it follows all the Zephyr guidelines by the book. Then you're going to have like a really, really good driver. The tool is going to help you even better if you know what to ask for. If you know there's guidelines for X and Y, you will be pointing them and using them in the prompt and things like that. So yeah, just quick check on time. Oh, not too bad. I have until the bottom of the hour, pretty much. It's about 10 minutes. Okay, they're not done patient. Yeah, that should work. Zephyr drivers. So moving on to more like writing code. Zephyr drivers, they are really fun or interesting, I should say, to write. Even like when it's your first driver, you're going to learn a lot, but you're also going to go through a lot of boilerplate, like and hooking up a new driver in Zephyr. Like we use device tree quite a lot, so you have to describe the capabilities of the particular peripheral you're trying to model and for which you're implementing a driver. All the kconfig options. You're going to have to basically just like dump and manually write from the data sheet. There's all those hardware registers that you will need to turn into macros. You will put tons of typos in there, one way or the other. It's yeah, really the definition of boilerplate, and that's one thing where LLMs actually work quite well. Provide the data sheet. Point again, this is where if you're knowledgeable about Zephyr, you're gonna have like really much better experience. You want a new driver for, I don't know, capacitive touch sensor. You know that it's very similar to driver X. So you're gonna provide the data sheet of your IC, point to driver Y. That's good enough, or like that should be a starting point, and off you go. And so yeah, quick demo. So we're going to switch to, I haven't decided yet. I think we're going to use cursor. It doesn't matter all that much, just to give you a sense of how it feels like for those who haven't experienced it. Yeah, capacitive touch sensor with a pretty crappy PDF and data sheet. This is a sensor that yeah, is used in a piece of hardware that I want to bring up. And how would this look like? You use the Chinese data sheet, probably more complete. It worked. That's true. Yeah, I mean, like this one, this PDF is the yeah, probably the poorly translated version of the data sheet, but it has probably all I need about like what are the I2C registers, etc., etc. And so I'm gonna pull in my I'm gonna make things as big as I can. So I have my like whoopsie. Where am I? Why did I? Yeah, so this is a Zephyr workspace. I just randomly dumped the PDF of the data sheet into the workspace. I'm going to add the data sheet to my context, and this is where I could also be like this. So it's a capacitive touch sensor. So in Zephyr, that's input subsystem and input drivers. So if I know about input drivers that are a good starting point, I could add them to the context. But this should be good enough. How about we create a new input driver for this sensor? Yeah, I didn't want to type. And that adds to the demo effect. And so I'm going straight into implementation. One thing that's interesting with most solutions nowadays is that you can first ask for a plan, effectively a markdown file that you can annotate, that you can comment on before it dives into implementation. Here, I'm confident enough that it will get it right the first time around. And I picked, so no commercial advertisement whatsoever, but in Cursor, they have like this crazy fast model. They call it Composer One, whatever that is. I think it's maybe Rock under the hood, so I'm not sure I actually want to use that one, but it's really, really, really fast. Let's see. We can already see in the Git unstaged changes, everything that starts popping up, the binding, binding. So the iteration I did an hour ago with I think a similar prompt, it actually went. It even created an example of how how one would instantiate the binding in their own device tree. But this one I think looks probably good enough. It is a nice grade C device. The device supports you can have an interrupt a pin to generate interrupt when there are touch events, or you can use polling mode, and then you have an array. Like this is a capacitive touch sensor where you have up to 12 things or keys that you can hook up to it. So it knows that it should be an input code array there. And then, I mean, yeah, the code is there. The, even if, so we could go and like double, like get the human cross check of the driver. I'm sure it got many things wrong in a sense, but there's also all the things that it got right, and that saves quite a lot of time. Like all those registers, it's nailed them. I'm pretty confident. And then, I mean, yeah, we have the rest of the code that follows. And if we're not happy enough, we can iterate further, or we could have done it with the approach I described before, where we do planning first before jumping into implementation. But yeah, we have, I mean, yeah, the kconfigs. It's hooked up into the build system, like all those little things. Yeah, questions, by the way, or thoughts, or and yeah, right.
I was just going to say one thing, experimentation I've been doing with someone else is putting the ask if you had any questions explicitly on the prompts.
Yeah.
Is to give you better results.
Yeah, yeah, that's actually part of the, usually when you use planning mode, it comes up with a plan and then some open questions. Things like, if you can clarify this, and that, you'll get even better results. Typically, for this, possibly it would have been like, so I'm going to write your driver. Would you also like the tests? And like, that's, but what you said also, I guess what I'm saying that now it's even baked in. Like you don't even have to ask. Please let me know if this is not clear, because it's already baked into the system. If it's not clear, it will.
Some systems have it, some don't.
Yeah. And you wanted to comment also?
Yeah. So it's impressive it can, basically implement all the dependencies and integrate with the building and everything. But wouldn't you want to build up when you submit it to the Zephyr project? Wouldn't you want to have commits that incrementally add it to the project, add the device provider?
Yeah, this one is it's a really good question. For this one, I guess that would typically be the commit. slash the PR. But when it needs to be more like staged, it's tricky actually to get the tool to help you. So you either like get to the point where you iterate to get the full thing, and then you as a human you do the work of splitting things, or you can try and get things iteratively and even get to the point where it does the commits. But yeah, you can also just time that way. But one thing that kind of like uh, part of the answer as well is one thing it's really good at, and frankly, when you do a lot of code contributions, that really helps, is things like, okay, well, I'm going to commit, well, I don't want to put the PDF probably, but I want to commit, and it's going to create the commit message. So I don't know, I don't remember if Cursor is going to do it, but typically yeah, it even knows like the kind of like the way we typically structure the messages, which is use the prefix corresponding to the aria, etc. And I mean, off we go. But then we can talk in a few slides, and I will be going over time. So I'm going to rush a bit. But then we should probably talk about copyright and stuff like that, because it's I just mentioned it. I'm not sure I have a good answer, but it's certainly something to be mindful of. Yeah, board definitions, that works really well as well. I guess this is already obsolete. I had this like a few weeks ago when doing the same kind of experiments. I would need, and similar to what Kate said, like this is something I don't need to say anymore. Like I would provide the PDF into the prompt and be like, do the driver for me, and it would just choke on it. It would like, it's a binary. What do you want me to do with it? I would need to explicitly be like, hey, maybe there's tools that can help, or you can use things like MCPs for those who are familiar with it. Now it's even like it knows it's a PDF. It did all the conversion under the hood, and yeah, I didn't have to ask for it. But yeah, sometimes what can help as well, even if you have them in the PDF or whatever is the reference, if you want to bring up a board, you have all those schematics for here's where the LEDs and the buttons, etc., are hooked up to the MCU. Attached to screenshots. That works surprisingly well as well. And yeah, point to similar boards. That's actually how we recommend it anyway in Zephyr. You want to bring up a new something board, take whatever board exists in Zephyr that uses the same module. Do a lot of copy pasting. That's actually how we recommend literally the documentation. Except here, I guess you get the agent to do the copy pasting for you, pretty much. Tests is also an interesting one, and this is an excuse for me to show or to remind people we have lots of stuff in CI, like I mentioned earlier, including code coverage. So we ran lots of tests, and we check that our code base is covered. This is also an area where it's really interesting to see what how tools can help. So we have this driver for kind of like a virtual device for an input driver where, why don't I see? Oh, this is an interesting, we are probably, CI is probably running, so the coverage is not, oh, it is. It's just the contrast that's really weird. There's green and red, which we don't see. I see here, whatever. You guys do see?
Here we can barely.
Wow, okay.
Yeah.
Here it's much different. Yeah, so there's a driver for something which is, I have a button that when I press the button, it generates key A. And this is a driver for for detecting double tap. You're like in your device tree, it would be like, hey, whenever key A is pressed twice in a short period of time, generate button X sort of thing. When you look at the test coverage, it shows that there's a bit of code in the driver that's not covered. So maybe this is dead code, or maybe that's a test that's missing. And so you can also like really, there's many ways to do it, but I'm gonna just copy the name of the function, whatever, and go back to cursor, be like, and I'm doing it like really the lazy way. This doesn't seem to be covered in test coverage at all. Fix it. Even my English is broken there. So I didn't point to the file. I should have, could have. It's probably going to save some resources, but even if I don't, uh, it's grabbing its way around. I guess it found already what I was referring to, and it's adding the test. And here I think it's going to be quite interesting to look at it because, I mean, yeah, by looking at the test it wrote, well, not only it's actually adding the coverage, but it helps. I mean, you can really quickly, as a human, it reads really well. You can be like, okay, yeah, that makes sense. That was indeed missing. So based on what I was describing just before, it added a test that if I press A, that's what I said earlier. If I press A, wait quite a bit, then press A again. It shouldn't generate shouldn't generate X. But then if I press A twice really fast, it should indeed generate it. So yeah, it did write the test. It adds the coverage, so it might help you spot again, like I said, dead code, and or it helps increase code coverage. And this is also arguably like tests in a way are also boilerplate code, and you can. And I think, I mean, I intentionally made this the really lazy and dirty way just to show you that if you invest even more time in it, you get even better results, obviously. So that's for tests. You could even do things like uh, take the giant code report that we get from running Gcode and whatnot, and be like, yeah, based on the code report, make sure that I have 100% coverage in file X, and then it would iterate and like parse the results and things like that. And then you can, as a human, again, you can be like, this was effectively dead code, etc., etc. This helps find holes in things that maybe also were poorly documented. Like maybe when you will read the test, you will be like, oh well, what the test is, what the comments read in the text in the test. This is what I should actually put in the documentation of my API, because that's how come this was missing. So yep, documentation is also really good at that. You want to add a new API, point at the tool to the good examples of things that are well documented, or even better, to our documentation guidelines. It will be like 100 times better than any of us will in terms of being super thorough, documenting all the error codes based on what your code actually does, and complying with the guidelines. No demo for that one, but that also works really, really well. The ugly, and this is where there's I ask many open questions. I don't have necessarily the answer to all of those. Copyright can certainly be an issue. Is the model trained on copyrighted data? We don't. I mean, we don't know. There's open source models. There's models that are maybe less open source. When you use the tool within your IDE, when it starts copy pasting nearby drivers, and we use some chunks of code. I mean, if the copyright is the Zephyr contributors, I guess you're fine. If the copyright is vendor X, you should, as a human, make sure that you put whatever copyright notices there. In a sense, I don't think it's much different from people copy pasting code from Stack Overflow, rest in peace, and things like that. It's just, I mean, yeah, we need to be careful, and I don't think any open source project is completely perfect in that area. Everyone tries their best. We have tools to help do like code fingerprinting, etc. But yeah, it could be an issue. Environmental impacts. Again, my take on this is it's just like any other tool. Yes, it can be very hungry in terms of resources. Hopefully, the training of the model is very expensive. The actual inference, the most recent studies are like, it's not where most of the consumption is, but still it's a tool that you should use only when really needed. But same with CI. Like we use tons and tons of like cycles of CI in the project. Is everything needed? Probably not. Does it consume the same amount of water and electricity than LLMs do. I don't know, but I know that we're probably wasting cycles there too. And then one thing to be careful about is that it can fuck up your brain in a sense. You're using those tools too much. And so you move from, I'm overwhelmed with having to switch from many PRs and cannot compute to I have this tool that is never tired and feeding me with lots and lots of stuff. It can, sometimes mess up with the brain in a sense. Give it a try, I guess, is my conclusion. And sorry for going over time. I don't think it makes any of us dumber, and I'm actually quite happy to see more and more people in the project using those tools. Like I mentioned, Copilot is actually getting involved in many pull requests. People summon it or like add Copilot as a reviewer. Don't think that yet. Don't think that makes us necessarily dumber. Need to be used critically. It's just that's what I had. Any thoughts? So before you send your you make your repo public, maybe you will have the tool and you'll pass. I don't know, like that's I would do it like that.
Yeah, just thought that I would. I have a question because at mine we tried something a bit similar with security related patches. So we tried to make an agent that would help us review commits regarding cybersecurity. We ran into some hallucinations, and we ran also into the fact that a lot of websites don't allow bots, which is understandable. But something I noticed while working on this is some effect, some psychological effects only. That when you see text getting printed really fast on the screen, you have this impression that a lot of work is being done. That it's right. When you even when you not even read it.
Yeah.
They you
It suddenly goes too fast in a way. But usually, I mean, I sort of look at the end result. If at the end of the day, I write the driver and it gets to the point that maybe with some help for me, that it actually compiles, it has tests, and it works, then I mean then you're like, okay, let's take a step back. Let's read through the thing. But yeah, it's yeah, like it has lots of weird psychological effects for sure. Yeah, but and this is where I would like double click on what I said before. If at the end of the day, what it spits, as someone who was used with Zephyr, it was if the result I get smells like Zephyr, and like I know of a few things that I look at to be sure, like, oh yeah, if it got this right, then there's a really good chance that it got the wall thing right, or the other way around. Yeah, that was yes.
I think with the human, that's a good assumption, but not with AI. If we got one thing right, AI is not going to.
That's yes, you're right. That's a probably bias. Yeah.
One of the things you're sort of seeing too is some of the AIs are great to actually meet our coding guidelines and making our coding guidelines more effective for AIs to read them to get them right. We don't need to correct things. It's also something you should try to look at.
Yeah. So that's I was thinking about this while driving on my way here. Just in general, even before going there, and there's some areas of the documentation where I try to use some tools for that. Even for us humans, there's many places in the documentation, including in guidelines, where we have something that's noise even for us humans. So let's just get, like, it's not adding any information. It's sometimes not that duplicated in different pages, etc. And for that too, we can get help removing some of the dependencies. And then maybe take it even further in terms of making it like JSON like or whatever, like pure, straight to the point for LLMs to consume. But yeah.
I find it, I spend a lot of time training it to do the same things over and over again, right? The agents.md helps. MCPs really help. But like you talk about, just because it did something right one time doesn't mean it's gonna do it right every time.
Yeah.
And you get used to it doing something right, and then it doesn't.
Yeah, and you stop checking for that thing that it will eventually get wrong. Yeah.
So like maybe putting all the documents here and there, and maybe actually creating test cases for each of those. Like sometimes it'll make them, sometimes it won't, sometimes it, so
Yeah.
yeah.
That's good.
In the ADC law that you found, so like you said, it's common. Like let's say that thread used to be in some other context, and so they refactored the code, and now that same block where the break was valid no longer, terminates that thread. But what if they put a comment that said, okay, don't retry, abort on the first error, so that we don't spam.
Yeah, well, so
would it have caught it in that case?
it would, in my experience, it would challenge it. I think it would see it and it would be like, okay, I saw the comment, but you should still do it differently, or there's another approach. And maybe sometimes it won't say, like Jason just said, like maybe sometimes it will ignore it. But I think in this case, especially since the pull request was reasonably small, things like that, it would change it.
And one last question for Bas. You mentioned that AI generated tests. I know this is a widespread practice and very valuable. But what do you think that for the long-term maintenance of especially big open source projects like Zephyr, would be a good idea to somehow tag the code with comments, the AI generated code with comments? If it works now, maybe it's fine, but maybe 6 months later, you will find out that there was problem with that.
Yeah, I guess it's an open question, because that whatever test gets added and is authored by AI, at least at this point, it would still be reviewed by humans, and humans would still vouch for the test and to be like,
You would not find people help to give a recommend.
yeah. But yeah, if we get to the point where we generate like thousands and thousands of tests just for the sake of adding coverage, but with the caveat that maybe sometimes those tests are meh, yeah, we need to do that. Yeah, good point.
I wrote something not for Zephyr, like for others. I had experiences also to add some unit tests, generate unit tests, and some kind of test reading development. It's quite low. Did you do this by time with that part, like using native state, or the central driver might be a little difficult to test it,
Yeah, like my experience is probably limited to things that's more library code and just like algorithms, if you will, and things that are arguably easier to test. Yeah.
But you could do it theoretically the same way with like more.
Oh yeah, yeah.
So I think Zephyr supports that quite well.
Yeah. Yeah, and one thing that I didn't mention is it's also really good for things that are maybe just the environmental impact that there, but throwaway scripts, like random things you want to like experiment, like especially if it's going to be Python, it's probably going to be even more efficient and smarter to do Python crap. But yeah, you want to like stats on your repo and blah blah blah. It's can help. Yes. What? Did you shut up? Lots of questions. Thanks. Yeah, that's what I had.